Assalamualaikum and have a very good day to my panel. My name is Putri Barazila binti Muhammad Abdul Aziz from AS257 Applied Microbiology with metric number 2023414402. And today I will be presenting my final year project titled Mycelium Running of Straw Mushroom Volvariella volvacea on pepper 8 tray and palm oil empty fruit bunch fiber as Lignocellulosic agriculture waste substrate, which supervised by Dr. Lily Shahani binti Rusli. Let me begin with the backgrounds of this study. Mushroom cultivation is one of the most sustainable agro-based industries that utilize agriculture residue to produce high-protein food source. Volvariella volvacea, commonly known as a straw mushroom, is highly nutritious, rich in protein, vitamin, and mineral, making it economically valuable in tropical regions like Malaysia. Malaysia generates millions of tons of agriculture waste annually, particularly palm oil empty fruit bunch or EFB. Meanwhile, pepper 8 tray, which are biodegradable cellulose-based waste, often end up in landfill, and these both material present opportunities for sustainable mushroom substrate development. However, the mushroom industry in Malaysia faces several challenges. First, there is limited availability of traditional substrate due to the increased demand from other industries. Second, palm oil EFB fiber, despite being abundant, it has limitation. The raw fiber has dense structure and high lignin content, which can slow down mycelial colonization and reduce biological efficiency. Third, pepper 8 trays remain an underutilized form of cellulose-based waste. Most importantly, beyond colonization speed, mycelial density and colony morphology serve as critical indicator of substrate suitability. Dense mycelial networks are associated with higher yield. However, these qualitative parameters remain unexplored for EFB and pepper 8 tray substrates. This knowledge gap leads me to my research question. This study aims to answer three key questions. First, what is the growth performance of V. volvacea mycelium when cultivated on pepper 8 tray substrate compared to palm oil EFB fiber substrate? Second, how does substrate composition influence the mycelial density and morphological characteristic of V. volvacea? And third, does a mixed substrate of pepper 8 tray and EFB fiber result in improved mycelial growth performance compared to individual substrate? To address this question, my study has three specific objectives. First, to measure the mycelium running rates of V. volvacea on pepper 8 trays and EFB fiber substrates. Second, to compare the qualitative mycelial growth characteristic of V. volvacea across different substrate formulation. Third, to identify which lignocellulosic waste substrate or combination promote the fastest and the most efficient mycelial colonization. This research is significant because it contributes to sustainable development goals, specifically SDG 12 on responsible consumption and production. Let me briefly review the relevant literature. Volvariella volvacea is a tropical mushroom requiring optimal growth conditions of 28 to 35 degrees Celsius and 80 to 95% relative humidity. Previous studies show that EFB with calcium carbonate treatment reduced colonization time from 15 days to just 9 days. However, there remain limited research on pepper 8 trays for V. volvacea and no studies exist on EFB combined with pepper 8 tray substrates. Now, let me explain my research methodology. I'm using 6 treatment groups. T1 is pure EFB as control, T2 is pepper 8 trays with 5% calcium carbonate, T3 combined EFB and pepper in 1:1 ratio, T4 is the same combination with 5% lime, T5 is pure pepper 8 trays, and T6 is EFB with 5% calcium carbonate. This experimental design is completely randomized design with 3 replicate per treatment, giving us 18 test tubes in total plus another 2 negative control. The procedure involves 7 main steps. Step 1. Pre-treatment. EFB is soaked for 8 hours and drained to achieve 60 to 70% moisture. While pepper is shredded, soak for 12 to 24 hours and squeeze to 70 to 75% moisture. Step 2. Substrates are mixed according to treatment groups with 5% calcium carbonate added to T2, T4, and T6. Step 3. Composting for 24 to 48 hours in black plastic bag at 25 to 28 degrees Celsius. Step 4. Test tubes are filled to 5 cm height with substrate and marked with 4 vertical lines at 90-degree intervals. Step 5. Sterilization by autoclaving at 121 degrees Celsius for 15 minutes. Step 6. Aseptic inoculation using 6 by 6 mm mycelial cubes in laminar flow cabinets. And step 7 is that incubation at 28 to 32 degrees Celsius with 80 to 90% relative humidity. For data analysis, mycelium running rates will be calculated by dividing the distance traveled in millimeters by number of days. Measurement will be taken every 2 days along the 4 marked lines on each tube. Statistical analysis will use one-way ANOVA with significance level of 0.05 followed by Tukey's HST test for pairwise comparison. Qualitative parameters including colony color and hyphal density will be scored using a 5-point scale from 1+ to 5+ sign. Based on literature review, I expect several outcomes. Mixed substrate which is T3 and T4 may show faster mycelium running than single substrate due to synergistic effect. Lime-treated substrate which is T2, T4 and T6 are expected to show improved growth rates through pH optimization. Pepper egg trays, which is T5, may demonstrate rapid initial colonization due to its high cellulose and low lignin content. This study has some limitations. Contamination risk will be mitigated through strict aseptic technique and proper sterilization. Environmental variability will be controlled using an incubator. The small sample size of 3 replicates is offset by standardized protocols for reproducibility. And while this is test tube scale research, it provides valuable preliminary data for commercial scale application. For a Gantt chart, this project timeline spanned 14 weeks. Weeks 1 to 2 for culture preparations, week 3 to 4 for substrate preparations, week 5 for inoculations, week 6 to 9 for data collections over 24 days, weeks 10 to 11 for data analysis, and weeks 12 to 14 for report writing. All methodologies and expected outcome are supported by peer-reviewed references which are listed in my presentation slide. I think that's all for now. Thank you for your attention. I'm happy to answer any question you may have about my research.